All right, so we're going to do another free response question on related rates today, and then you guys will have a couple practice problems for homework. So objectives, we're still using implicit differentiation to determine rates of change in a function. We'll also be looking at some integrals as well. So this is from way back, but if we have a scalar quantity, that means we only have a magnitude, so that's an amount. Amount
Mm-hmm.
only. If we've got a vector, then we have an amount and a direction. And direction. Okay, so I've got a couple examples here. Distance is a scalar, displacement's vector, speed is a scalar, velocity is the vector, magnitude of acceleration, and acceleration, because we don't have a word in English for this scalar acceleration. So we don't have a word for it, we just write magnitude of before it. Same thing for the jerk, magnitude of jerk. If I wanted to go down this chart, so if I had an equation for displacement, and you wanted to go down to velocity, I would derive. So derive your displacement in terms of time to get velocity. So I could say this would be, your displacement's usually written s in terms of t, or x in terms of t, one or the other. Velocity then would be ds over dt, which is equal to vt. Space this out a little bit better. So your velocity at any time is equal to your change in s over change in time. Your acceleration at any time, that's at, would be equal to the second derivative of s in terms of time, or the derivative of velocity in terms of time, which means the same thing. I don't have a subscript for jerk, so this would be a prime t, dA over dt, d3s over dt cubed, or the second derivative of v in terms of time squared. Okay, so point is, if I derive down, you'll move down this chart. If you integrate, you'll move up this chart. So if I was going to integrate velocity from time A to time B, then I would get your displacement. Okay. So if I integrate this, I'll get an upper bound minus a lower bound. So it'll be my velocity at time B minus my velocity at time A. Integrate, that'll be displacement. Okay, but we already had some displacement at B as well. So this will be my change in displacement from B to A. Okay, if you just integrate Vt and you've got a function, so if I did this, where we don't know what the bounds are, if I integrate Vt, I would get an equation for what our displacement is at that time plus a constant. This constant is your displacement at time 0, or your initial displacement. Okay, any questions on the chart?
Yes, what is the magnitude of jerk again?
So this is the amount of jerk that you feel. So jerk is the derivative of acceleration. You can think of it as how fast the acceleration is changing. We measure it in meters per second cubed. Magnitude of the jerk is just how much jerk you have. Jerk would be how much jerk plus a direction. So maybe 3 meters per second cubed north, or 3 meters per second cubed up would be your jerk. And the magnitude of the jerk in that case would be 3.
Okay.
Okay. So these rates don't have to be physics related. It could be anything. So for instance, here I've got the number of people in a cafeteria, which I would measure in people. My rate of change would be the change in people in the cafeteria. And then how fast that rate is changing would be my people per second squared. So if I wanted to write that out, I could say P is my people right now that are in the cafeteria. My dP over dt is how fast that how fast the people in the cafeteria are changing. So that would be how fast people enter and how fast people are leaving. And my second derivative would be my derivative of that rate, which would give me the acceleration of people in the cafeteria, or how fast the rate of change in people in the cafeteria is changing. So again, that would be the change in the rate over time of people entering minus the change in the rate over time of people leaving. Okay, if you started with a rate, which is what College Board really likes to do with their free response questions, because it allows them to test you for both integration and derivatives in one step. If I start with that rate, then in order to get to the number of people in the cafeteria, I could integrate. However, we can assume that there was a starting number of people in the cafeteria, so I'd have to add that number of people first. So when I integrate the change in people, which is how many people were entering minus how many people were leaving, I would have to integrate the number of people entering, and then subtract the integral for the number of people leaving, and then add how many people were in the cafeteria at the starting time. Okay, any questions on this one?
No.
Okay, so let's try one. Okay, so here I've got water that's being pumped into an underground tank at a constant rate of 8 gallons per minute. But water is leaking out at a rate of t plus 1 gallons per minute for the first 2 hours. At time t equals 0, the tank contains 30 gallons of water. Okay, so I'm going to draw really quick. You guys don't need to do this on your test, but... Okay, so here's my tank of water. We are pumping water into the tank. So, water's coming into the tank at a rate of 8 gallons per minute. And then water's leaking out at a rate of root t plus 1 gallons per minute. Okay, at t equals 0, we already have 30 gallons of water. Okay, any questions on what's happening, just as far as English goes?
No.
No.
Okay, cool. So the first thing we need to do is figure out how many gallons of water are leaking out of the tank from 0 to 3 minutes. What do I have to do?
The integral from 0 to 3 times and then the rate.
Okay, which rate?
The
So
rate.
we've got 2.
The increase minus the decrease,
So I'm gonna hold that
or just
because
the decrease?
we'll need that for part B. But for part A, we're just looking at how many gallons of water we're leaking out of the tank. So we don't care about the water coming in or how much water is actually in the tank right now. So this is, I'm going to integrate our rate out. I'm going to call my rate in will be PT and my rate out will be LT. So that's for pumped and leaked respectively. So I'm integrating I'm integrating our rate at which water is leaking out of the tank, which is LT, in terms of time. Okay, be sure you write what you're integrating in terms of as well to get full credit for your integral setup. Okay, so this is the integral from 0 to 3 of root t plus 1 dt. Okay, how can I integrate this?
Rewrite t over 1/2,
Okay, so I think you're
and
doing
then
a u sub for me. So if u is t plus 1, u prime is dt. So this is really u to the 1/2 power. Okay, if I integrate u to the 1/2 power, what will happen?
u to the 3 over 2 power.
Okay. See, I'm going to change my bounds there too. So this was 0. What should my new bound be here?
1 and 4.
1 and 4, perfect, because u is t plus 1. So 0 plus 1 is 1, 3 plus 1 is 4. Okay, and you said this would be u to the 3/2 power, and then divide by the new power. So if I'm dividing by 3 over 2, then I'm really multiplying by 2 over 3. So if you divide by a fraction, you can flip and multiply. And my bounds are 1 and 4. Okay, so then I can plug in my bounds. If I take the 3 over 2 power of 4, that over 2 is a square root. Square root of 4 is 2. Raised to the 3rd power is 8. So that's 2 times 8 over 3 minus 1 cubed is 1. The square root of 1 is 1 times 2 over 3. So I have 2/3 times 8 minus 2/3 times 1 is 2/3 times 7 is 14/3. Okay, what are my units? Junho. Okay, 14/3.
Gallons.
Gallons, perfect. Okay, 14/3 gallons of water. Any questions on part A?
No.
No.
Okay, I'm gonna make a break here, just that's a little bit easier to follow maybe. So did I use substitution and then came back up here? Okay. So 14/3 gallons. Okay, part B. I want to know how many gallons of water are in the tank. Since Oliver mentioned this already, to get the gallons of water in the tank, we're going to need to use both the rate at which the water is leaking out and the rate at which water is pumped in. So I'm going to keep this 14/3 gallons because that's how much water we leaked out total when we write our formula. Okay, Junho, if I want a formula for how many gallons of water total would be in the tank at 3 minutes, what would my formula be?
Root.
Okay, so I've got 3 parts. First, how much water you started with, how much water went into the tank, and then how much water went out of the tank. So, how much water did we start with?
Uh,
Question was, how much water did we start with?
how much?
Okay, so
30.
30, okay. So my starting amount, which was 30. I'm going to write a general form first. This is G at 0. And then I'll go down here and write 30 for the next line. Okay, then I have to add my water in. So we were told that the water is coming in at a rate of 8 gallons per minute. So if it's coming in at a rate of 8 gallons per minute, how much water came in after 3 minutes?
Oh, 8. 24.
24. Okay, so that is the integral from 0 to 3 of 8 in terms of time. And then we're going to subtract our water out, which we said last time was the integral from 0 to 3 of LT dt, which we already found the value of in part A, so I'm going to jump back, was 14/3 gallons per minute. Okay, so now I can just add these. So this is G at 3 is 54 minus 14/3. Which is the same thing as 162/3 minus 14/3, or 148/3. Does that reduce? So this 3 would go into 14 12 times. Okay, give me 28, which is not divisible by 3. So I'm going to leave this as 148/3. What are my units? Sorry, say
Just
again?
gallons.
Just gallons. Okay. Okay, so that was Junho, and the next one's Oliver. Write an expression for the total number of gallons in the water at the tank at any time t. Sorry, it's a little fast. You can take a picture again.
Yeah, I did.
Okay, cool. So I want a general expression for the amount of gallons in the tank, AT.
It's just 30 times the integral
30, not times.
plus
Okay, 30 plus.
the integral of the rate of of pumped water which gets inside
Okay.
minus the rate of gallons per minute which leaks.
Okay, you're right. We're gonna write in formulas for those though. What's the rate at which water is pumped in?
8 gallons per minute.
Okay, so that's 8 dt. And we're integrating from 0 until what?
T.
T. Okay. And my water out is also from 0 to t. And that's going to be our LT, how fast the water was leaking out, which is what?
Root T plus 1.
Root t plus 1 dt. Perfect. And I believe that's it. They just asked us to write an expression. I could integrate this part directly if they wanted, I guess.
Mm-hmm.
Okay, let's do that. So this will be, we'll simplify once. AT is equal to 30 plus, what happens when I integrate this?
AT from 0 to T.
Okay. Which, if I do upper bound minus lower bound, will give me what?
AT.
AT. Okay, minus, let me write that T. 8 T, there we go. Minus, I'm going to keep this as an integral. The integral from 0 to T root T plus 1 dt. Okay. Last one. Figure out what time the amount of water in the tank is at a maximum, and then justify your answer. Okay. Junho, in general, what do we have to do if we want to maximize something?
이거 slope positive to negative.
Okay, so figure out when the slope changes from positive to negative. So I want what time the amount of water is at a maximum. The slope of the amount would be my change in water over time. Would be A prime T is equal to my rate in minus my rate out. Or PT minus LT, which we said was 8 minus root T plus 1 dt. Okay, so if this is the slope, in order to get a maximum, I need to figure out when the slope is 0, and then we can do our derivative test, right? So I'm going to set this equal to 0, and we'll solve for t. What do I have to do next?
Minus 8
Okay, so that gives me root t plus 1 equals 8.
스케일
Square both sides. T is... t plus 1 is 64. Therefore, t is 63. Okay, at 63 seconds, we have a critical point. But I do need to test and see whether that critical point is actually a maximum. So which test could we use? Do you want first derivative test or second derivative test?
first.
Okay, first, that's fine. So with the first derivative test, I'm going to plug in values around 63 into our first derivative, which is here. So if I plug in t equals 0, will my answer be positive or negative?
positive.
Positive. If I plug in t is 1,000,000, will my answer be positive or negative?
Negative.
Negative. Okay, so is t equals 63 a maximum or a minimum?
Maximum.
Maximum. Okay, so we just need to justify our answer now. So if I could say the amount of water in the tank is at a maximum at t equals 63 as a prime t, which is capital A, as a prime t is positive, greater than 0, on the interval 0 to 63, and a prime t is negative, negative on the interval after 63 to the end of our interval, which is 120 minutes. And a prime t, a prime, oops, at 63 equals 0. Okay. Any questions on what we did?
No.
Okay, so I'm going to go back and we'll check our answers versus the scoring guide really quick. Here. Okay, so for the first one, definite integral limits integrand and answer. So from 0 to 3, integrate root t plus 1 for part A, and then get 14/3. We integrated 0 to 3 of, okay, that's right, so that's 2 points for the integral and limits, and then 1 point for 14/3. Okay, so that looks good. Okay, so that's 3 points for part 1, and then part B, 1 point for answer of 148/3. 148/3, okay, we're good for that. Part C, okay, 1 point for 30 plus 8t, and then 1 point for subtracting the integral from 0 to t of x plus 1. Okay, we did that. So 2 points there. And then sets a prime t equal to 0. We did that for part t. Solves for t, 63. And then justification, we're positive before 63, negative after 63, and have a maximum. Okay, we've got a maximum at t equals 63 because we're positive before and negative after. Okay, I think we would get full credit for all of this. Any questions on what we did?
No.
Cool. So the homework is numbers 1 through 3. For the FRQs for Calculus AB 1999, which I've linked in the Skype chat and the WeChat. If you have not sent me any of your stuff from last week, so that's your tests, please make sure you get that to me at some point today. So I'm going to be grading those tonight.
Okay.
I think I haven't actually downloaded from course sites yet, so if you submitted from course sites, then I haven't checked. And then Oliver, I saw I got something from you this morning.
Okay.
Okay, thank you very much for coming, and I'll see you guys on Thursday.
Okay, thank you.
Have a
Bye.
nice
Bye.
day.
You too.